Me too.
All right. Hello and good day, pre-algebra. We've reached the end of the unit, or at least the last objective. This is probably going to be a 2-day extravaganza. Tomorrow is going to be a retake day in class, so plan on practice work. Last week, there were a number of you that didn't really get anything done, not super productive. So tomorrow, please make sure that you come with stuff to work on, because as we start taking tests, objectives start to pile up, and that's when, falling behind doesn't really serve you very well. So, retake day tomorrow, so plan on a test next Wednesday, Thursday, probably a two-day, we'll see what happens. Anyway, CO6, kind of the opposite of the greatest common factor. We're looking for now least common multiple. You've heard of this before, you've done this before, but again, we're going to look at kind of some word problems with it, similar to how we did with greatest common factor. Let's start by reviewing factors and then talking about multiples and how they compare and contrast. So what are the factors of 12? Factors of 12. Dominic. 1 and 2 and 3 and 4 and 6 and 12, right? A factor is a number that goes into another number evenly. So 1, 2, 3, 4, 6, and 12, they all go into 12 evenly. Okay? What are some multiples of 12? Get me started, Ava.
6 and 2.
So you're thinking factors again.
Oh.
Right? We already have the factors over here. Multiples of 12. Yes, Claire's saying, isn't it more? So the first multiple of 12 is itself, because 12 can go into 12. What's the next multiple? 24.
Oh, I thought you meant what multiplies. Like what two things multiply.
Nope, that would be what two things multiply to make 12. Or the multiples of 12. 12, 24, what was 36. And then, Dominic, 48. And then 60. And then 72. And then 84. And that continues on. Right? Notice my wording here, how I asked these first two questions. I said, what are the factors of 12? Because there's only a certain number. These are the only numbers that go into 12 evenly. These are the factors. Versus over here, I said, what are some multiples of 12? Why couldn't I possibly write them all?
Oh, they don't stop.
They don't stop. They go on forever, right? And so one difference between factors and multiples is that factors, there's a finite set. There's only a certain number of factors a number can have, whereas multiples go on forever. Okay? Factors are all, with the exception of 12, smaller than the number that you start with. Multiples, with the exception of 12, are all bigger than the number that you start with. Okay? So how would we define a multiple? If a factor is a number that goes into another one evenly, 2 goes into 12, 3 goes into 12, what would a multiple be? I'm asking you, what would be a good definition for a multiple? Yeah. A number that 12 can go into. Let's call it that numbers you get. This is a very informal definition, by the way. I'm trying to make it so you can kind of understand it here. Numbers you get by skip counting. Right? Remember skip counting? Count by 2s. 2, 4, 6, 8, 10. Count by 3s, count by 5s. Okay? When you skip count, all the numbers that you say are multiples of whatever you start with. Okay? Skip count 5. 5, 10, 15, 20, so on. Those are all multiples of 5. Here we skip counted by 12 and got multiples of 12. Okay? We're going to talk about two methods, again here, to find the least common multiple of two numbers. we're going to use 6 and 10. And I'm going to erase this so I can get both methods on the same page here. Does anyone else still need the notes from up top? Are we all good? Okay. All right. So using 6 and 10, we can find the least common multiple using the MCL method. Basically the same thing as listing for a table. Okay? What? Do you have a question?
Me?
Yeah. Oh, do you have a question? Well, we haven't done anything yet, so there's nothing to be confused by unless it was the top part, but. No, good, okay. So, first thing, we are going to use 6 and 10, so that's where these numbers come from here. And we're going to start by listing the multiples of 6 and listing the multiples of 10. Just skip count by 6s and skip count by 10s. Ready? Here we go. 6, and then,
12,
and then,
18,
and then,
24,
and then,
32,
and then,
36,
and then,
42,
and then,
48,
and then,
54,
Isn't it 54?
and then.
60.
All right, we'll stop right there. Okay, so we're already seeing the disadvantage of this listing method is that if you add incorrectly, it can really throw you off, right? I heard someone say 24 plus 6 was 32. We had someone say 48 plus 6 was 56, right? So the disadvantage to this is that if you add wrong, you're in a little bit of trouble because you're not counting by 6s anymore, okay? Let's do 10s though, skip count by 10s. 10, 20, 30, 40, 50, 60, and we'll stop right there, okay? Because our goal is to look for those common multiples. So here we have our list of multiples for both 6 and 10. What numbers show up in both lists?
30,
30 does,
and 60.
and the 60 does. Okay? So our common multiples, the ones that show up in both lists, are 30 and 60. If we continued the lists, would there be more?
Yeah.
Yeah, what would the next common multiple be? Anyone kind of see a pattern developing here?
90.
90 would be, right? And after that is 120, then 150. Every 30 is going to match up,
Oh.
okay? Which is why we are looking for the least common multiple. Because the common multiples, just like the multiples themselves, will never stop. If I asked you for the greatest common multiple, you'd be counting forever. That'd be really mean to me, okay? We're looking for the least. So, of the ones that we have here, what's the least one? What's the first one? 30, right? And so that would be the solution. Okay? That would be the solution. Again, I caution with the listing method just because it is that opportunity to make a mistake. There was a student I had who graduated way back in 2010. Was that, you weren't even alive in 2010, right? No. But I told her I would tell her story forever just because I didn't want to forget this. When she took her test, her Unit 1 test, least common multiple was on it, and she was using the listing method for, I don't remember what the numbers were, but she got off in her counting, like some of us did right here, and she ended up writing multiples all the way across the top of the page, all the way down the side, all the way back, and all the way up. And finally she comes up to me and she's like, what is this? I can't find a common one. And she made her mistake like way back here. And it was just like, oh, Lily, oh, I'm so sorry that you wasted all that time. You gotta be very, very careful, okay? She's fine now, by the way. Like, there's no, she turned out okay, right? But it was touch and go for a while there. The other method, similar to greatest common factor, is the table method, right? But to find the least common multiple instead. Ava.
Well, I have a question. On the test, if you use the least common multiple method, could you use your assignment notebook to look at the numbers?
No. You can use a help sheet, so if you want to write that in there, and you can use a calculator also.
You can't
so
use the multiplication.
not in your assignment notebook, no. I'm giving you a calculator.
What if you just write all the numbers down?
If you write them all down, sure. But you can't use yours as a
Can
sound
I
notebook.
print one out and then show you?
You can, if you want to type your help sheet and insert a table into that one, sure.
Oh, okay. Ooh.
But again, you have a calculator.
No, because
as
it's
well.
easier so then you know exactly what goes in
Yeah.
there and you don't have to like
Yeah,
look,
don't
try.
be, no, don't be that kid in high school that asks to use a multiplication table. I'm just gonna, I mean, especially if you have a calculator, like, you know, at that point, we should graduate from them. Anyway, so 6 and 10, we're gonna make a table similar to how we did with with greatest common factor. I'm gonna leave a little bit of spaces here. I made my numbers a little bit too close together. So 6 and 10, and there's that, okay? And we're gonna start the same way as we do with greatest common factor. Do you remember this from last year? Did Gavino show you? Okay.
Maybe.
What goes into both 6 and 10?
2.
2, right? So the 2 goes outside here, and we're going to divide by 2 and divide by 2, again, just like we would in greatest common factor. Okay? So 6 divided by 2 is 3, 10 divided by 2 is 5. Right? Now, what goes into both 3 and 5? Nothing. 1, right? And like we've said before, when you get the 1, that means
You're done.
you're done. But here's the difference.
We will call
In-
you when you are ready to come down for the pictures. We're running just a little late. Thanks.
Shocker. In greatest common factor, what would we multiply here? The 2 and the 1. This, however, is least common multiple. Least common multiple. You are going to multiply in an L shape,
Oh, I remember this.
right? So least common multiple, you're going to take the L, right? Take the L. Even these two numbers that are left over, they end up getting multiplied. So 2 times 1, which doesn't change anything, but it's there, so we'll include it, times 3 times 5 equals 30, which is the least common multiple, the same number that we got up here. Okay? So with least common multiple, the table method, just remember, take the L. Okay? Take the L. Well, then do the other method. Questions on that? Okay.
Oh my gosh.
We're going to go down, do a little more practice here. We're going to use both methods for 15 and 21. On the second page, when you start to do your homework, you can pick which one you want to do, but we're still going to practice both. Okay, just so you can decide, this is the one I really like. And you can see the advantages and disadvantages of each of them. So starting with 15, the listing method, let's skip count. Here we go, skippity-doo-dah. 15, then,
30.
then,
45.
then,
60.
then,
75.
then,
90?
then,
105.
then,
120.
then,
135.
then.
150.
All right. Now, again, another disadvantage here. We don't know when to stop. Wait, you say something wrong?
No, sorry.
Oh, yeah. How do we know when we should stop? We really don't know, right? Because we don't know where these two lists are going to cross. But we went out 10. That's a good start. We'll see what 21 gives us, and we'll go from there. Skip count by 21s. 21. Then
42.
42.
64?
Ooh.
Oh.
The cursive
Oh,
lily.
it's 63.
63.
84.
84.
105?
105. Oh, wait, that sounds familiar. Aha! No need to go any further. We have found the least common multiple, 105. Okay, once you find that first one, don't go any further. You're looking for that first one anyway. Okay? So 105 is our answer. That's what we're going for. Let's see if we can find it here with the table method. So again, we're going to make our table. Here's 15. Here's 21. Okay? What goes into both 15 and 21?
3.
3.
Oh, jeez.
So divide by 3. Divide by 3. That gives us 5. and 7. Right?
Yeah.
What goes in both 5 and 7?
One.
1, which means we're done. And since we're doing least common multiple, we are going to take the
L.
Take the L. Take the L. All those numbers get multiplied together. And what should 3 times 1 times 5 times 7 give us? 105. Does it? Yes.
Oh.
So we know that we're good. Okay? So we know that we are good. Questions on either method here? All right. 3 numbers now. Oh boy. Here we go. 9, 15, and 18. Let's start skippity-doo-dah. 9. Then.
27,
Then.
36,
Then.
45,
Then.
54,
Then.
63,
Then.
72,
Then.
81,
Then.
90.
90.
Can't even keep up. Yeah, what?
We'll stop there. We'll go 10 out, see what happens. We don't know exactly where these numbers are going to cross, but it's a good start. I'll leave a little space in case we have to do some more.
Oh, we have 15 again.
We do have 15 again. That's nice. We can just kind of copy what we have here. 15,
30.
30, 45, 60, 75, ooh, 90. Hey, I like that.
Oh, and 45. Wait.
And 45?
Oh,
And
yeah.
45. You're right. I missed that one. Yeah, okay. So we got some common ones here. Now we're looking at 18. 18. Then
36,
36,
54.
54. Oh, there's a 54 in 9, right? Is that our least common multiple?
And there's a 36 in 9.
And there's a 36 in 9. Do we have it? And there's an 18 in 9. Oh, but there's not one in
There's also a 90.
15. Okay? Eventually, we do, after 72, we get to 90. Okay? So with 3 numbers, we see some pairings here. Someone pointed out that 45 appears in both 9 and 15. 18 appears in both 18 and 9. So does 36. So does 54. But the first one that appears in all of them,
90.
90. And so 90 would be our answer. Okay? It's got to be the one that appears in all 3 lists. All 3 lists. Right? Okay, let's table this for now. Did it? Because we're doing the table method next. We're going to table this. No? Okay.
No.
Table this for now means like save it for later, but because our method is called the table. Okay, never mind.
Oh.
Make our table. We got 9. We have 15. We have 18. Okay? And what goes into 9, 15, and 18?
3.
3 does. So we're going to start there. 9 divided by 3, 15 divided by 3, 18 divided by 3. We get 3, we get 5, we get 6. Anything going in 3, 5, and 6?
No.
No, but
1.
1.
Right? So we're done. But wait a minute. If we multiply 3 times 1 times 3 times 5 times 6, do we get 90?
I don't think so.
We don't. Okay? We don't.
70.
Another subtle difference between greatest common factor table and least common multiple table will be given to you shortly. Yellow. No. She would be in the science room in theology. Yep. Bye.
I know.
Okay. So the other difference between GCF and LCM in the table is that in GCF, we're looking for what goes into all of them. And if this were greatest common factor, we'd be done. With least common multiple, we're looking for what goes into any of them. Do you see a common factor between any 2 or 3 of the numbers? 3. 3 goes into 3 and 6. It does not go into 5, but that's okay.
Oh, don't you bring it down?
Okay, we bring it down. So 3 divided by 3 is 1. 5 doesn't go into this, that's okay. 6 divided by 3 is 2. Now, there's nothing that goes into 1, 5, and 2, any combination at all. We can't take anything out of any of them. So now, we're done. Okay? And here's where we take the biggest L you've ever seen. Okay? Least common multiple, take the L. We're multiplying all those numbers together. We have 3 times 3 times 1, which doesn't change anything, times another 1, which still doesn't change anything, times 5 times 2, and if you multiply all those things together, what do you get? 90. Okay? So, you've got both methods up there. Okay? Just initial thinkings here. Who's a bigger fan of the listing method? Who likes that more? A couple. Beware of the lily curse. That's all I'm going to say. Who likes the table method more? Who loves them both? Because by golly, it's math. Okay.
I have a question.
Yeah.
What if you were, like, if you're doing the, table method?
Yeah.
And there's one number that can be divided again, but then 2 can't. Can you still divide it down or no?
You're looking for what? Like what? Give me an example.
Like if it's like 6 and 5 and 5, can you divide the 6 by 3?
Well, no, but you could divide the 5s because 5 goes into both of them.
Oh, well, no, let's just say it's like 6, 5, and 1.
Like 1, 5, and 2 here. Like no, we
Yeah.
wouldn't divide the 5 by 5 because there's nothing else we can divide by 5 with.
So if there's only one number that can
Right.
be multiplied.
Otherwise, yeah, correct.
Okay.
Yes. All right. Other questions? Yeah.
Can we use our multiplication table on like the binder?
Yes. If you want to use your multiplication table on the binder, that's fine. If you want to use your calculator on the binder, that is fine. If you want to use a multiplication table on the test, if you want to write one or make a printed help sheet and put one on there, copy and paste, that's fine. But again, you know, you've got the tool of the calculator. I would like you to move toward knowing how to use that, because eventually you're going to deal with numbers that aren't on the multiplication table. You know, just because you're getting to 7th grade pre-algebra, numbers just get larger, and so the calculator is going to be the better option in the long run. Okay. Your homework for Monday, because tomorrow is a retake day, is the entire second page. Don't worry about the word problems. The 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them to do. You can use either method, but you must show your work. You must show your work. If you use the listing method, I need to see your lists. If you use the table method, I need to see your table. If you just have an answer, I'll say, I can do it in my head. Great, but show me a method. Show me a method. Questions, comments, concerns, complaints, compliments, congratulations, criticisms? Ava.
Can you do it like for the table method? Can you just divide it by 1 if there's nothing? You know, what do
Yeah,
you-
so for 3 and 8, if you're using the table method here, and you realize there's nothing I can go into 3 and then go into 8, I'm done. Then there you go.
Oh, yeah. So it's just 3 times 8. 3 times 8.
Yep, it would be, that one. I think that's the only one though.
Wait, for what?
Like, if you're using the table method for 3 and 8 here, and you make your table, and you put them in there, and you're like, there's nothing that can go into 3. I can't reduce either of these, so I'm going to take my 1. This will be not a very big L, but yeah, you would just end up multiplying just like that. All right, anything else? Okay, folks, you got 5 minutes to work with gusto.
That's right. Like and subscribe.